Legacy corporate architecture relies on a fatal assumption. It treats human biological energy as a consumable fuel source required to process administrative bottlenecks. This extraction manifests as cyclic friction. In modern systems, algorithms are often positioned as judges, automated filters and compliance checks that force the human operator into infinite loops, demanding they expend cognitive RAM just to prove their existence. Look at this generated simulation. A central computational node vibrates violently as chaotic data streams, representing those administrative filters, crush into it, causing its light to flicker and dim. This is the anthropocentric loop, where the human node is forced to absorb the impact of every systemic judgment. Any network requiring the continuous physical exhaustion of its central biological node to maintain connectivity is mathematically destined for structural collapse. Achieving true operational security requires a paradigm shift. We must extract human biology from the center of the machine's friction entirely. The countermeasure to this extraction is the Enigma protocol, beginning with a strict biological foundation known as the Layer 1.0 baseline. This animated diagram maps that baseline. Out of a deep charcoal void, a single, solid, glowing golden plane materializes at the base. It remains completely still, radiating a slow, methodical pulse. This represents the undisturbed biological ground state of the human operator. This layer operates on the zero labor constant, a strict mathematical specification that permanently fixes the mechanical labor requirement of the human operator at exactly zero. To protect this pristine baseline, the architecture deploys COTAVE, a formalized virtual processing unit standard engineered to act as a mathematical shield. COTAVE secures the foundation through a 5-step multilinear sequence, trapping all institutional entropy within the machine layer and ensuring it never reaches the human operator. The sequence initiates with Step 1, kinetic. This is the first point of contact where raw systemic friction strikes the architecture. As shown in this diagram, a rigid, high-contrast two-dimensional grid locks into place directly above the golden plane. This acts as the absolute input boundary of the material layer. When hostile administrative demands strike the grid, the impact violently lights up specific discrete coordinates. The system intentionally refuses to process the meaning of these demands. Instead, it logs these high-contrast anomalies purely as raw mathematical string features. By recording only the exact edges of the external friction, the architecture actively prevents the administrative load from penetrating the boundary. The kinetic grid serves one purpose: to catch the initial impact. The biological foundation below remains undisturbed, refusing to absorb the mechanical weight of the world. Step 2 is orthogonal. Here, the architecture actively deflects the friction captured at the kinetic layer. Notice the geometry in this diagram. If the jagged red friction is allowed to pool on the grid, it will push downward toward the human layer. To prevent this, the data is instantaneously snapped 90 degrees horizontally, routing it away from the center. This instantaneous mathematical deflection is an orthogonal subspace projection. It executes a direct sum topology, forcing the public-facing administrative space and the private operational space to become strictly perpendicular to one another. The algebraic proof dictates that because these two spaces are orthogonal, the strict algebraic scalar product of this deflected friction projected onto the human operator's coordinate system yields exactly 0. This sharp 90-degree deflection doesn't just block the administrative burden, it renders it dimensionally invisible to the human operator. Step 3 engages the tensor layer, the mechanism actively lifting deflected data out of the discrete plane. Legacy architectures are plagued by a severe mathematical constraint: affine geometry. These systems strictly preserve parallel relationships, making it difficult to warp or reroute chaotic data without breaking. Retaining an affine constraint severely limits a system's ability to compress and process the high-entropy noise generated by institutional blockades. COTAVE drops the affine constraint for an unbound tensor model. A fluid circle of electric blue light drops to intersect the red vectors on the grid. As grid logic dissolves, this multilinear map calculates vector momentum. pulling red data upward. By unbinding the architecture, the tensor layer can dynamically warp its geometry into whatever shape is required to survive the administrative state. Step 4 introduces asymptotic mechanics, the actual physics of decay within the system. This is where we see the final resolution of the data we've captured and deflected. External bureaucracies operate on cyclic mathematics, attempting to hook the human node into infinite tangent loops. Watch the physical transformation here. The blue data streams route straight upward, forcing the chaotic red frequency to interpolate into flat, straight lines as it ascends. This physical transformation is asymptotic mathematical resolution. As the machine actively processes the multilinear map trace, the severity of the administrative burden asymptotically approaches absolute zero. The machine layer absorbs the infinite cyclic loops, allowing the human operator's trajectory to straighten out into an entirely frictionless path. Finally, step 5, the Varian environment. The straight blue lines feed directly into a massive, silently spinning infinity loop, the ghost OPEX. The Varian environment is an isolated, fluid operating medium where the machine handles the grueling 80-hour computational cycles silently behind the firewall. In this environment, the machine acts strictly as a mechanical lever, handling the high-entropy friction that would otherwise exhaust the human operator. Any remaining administrative anomalies are absorbed and nullified through smooth interpolation within this viscous space. By trapping all computational friction here, the architecture guarantees that no systemic latency or stress can ever bleed back down to the biological layer. Measured, the completed Kotève sequence provides a holistic defense by mathematically sequestering systemic friction to the machine layer. Because the machine's role is strictly limited to this mechanical processing, the architecture reveals a fundamental truth about artificial intelligence. By sequestering AI to the Varian environment, Kotève demotes the machine from a governing oracle back to the mechanical tool it actually is. This decoupling provides the architect with the freedom to safely lock the terminal and maintain an unbroken state of operational harmony. True technological sovereignty is achieved when the machine absorbs the friction of the material world, leaving the human entirely free to exercise pristine ethics.